Okay, so we're going to be talking about one-factor medication problems. And medication problems can be solved using 5 steps of dimensional analysis. So when we talk about one-factor medication problems, we call it that because there's one element involved in the physician's order. So the first step in dimensional analysis for solving one-factor medication problems is to interpret any of the physician's orders or the practitioner's orders. We have to be identify the given quantity or what is the exact dose that the physician has ordered. So if you look at this problem, it says the prescriber orders 250 milligrams of a medication. So our given in this case is 250 milligrams. The second step is to identify what is the wanted quantity. What is the answer we are seeking to the problem? Well, how do I know what is wanted in this problem? Well, I have to look at what's available, and it's tablets. So my wanted is tablets. And I'm going to put this over a line because this is going to represent what I need in my numerator. All right, so my given is 250 milligrams. My wanted is tablets because that's what I have available. The third step is to establish any unit path. So is there anything that I need to do from what's given to what's wanted? And there is. I have to figure out how am I going to convert this 250 milligrams order into tablets, and I'm going to use what's in my problem. And what's in my problem is every tablet that maybe the pharmacy sent is 100 milligrams. So my unit path or my conversions is, you can write it as unit path or what's available is 100 milligrams in every tablet. So when I have this information, the fourth step is to actually set up the problem. And we always set up problems to cancel out the unwanted. So if I know my wanted is tablet, I have to make sure I'm able to cancel everything out. So how do we set up a problem when it's one factor? We always start with the given. And our given in this case is 250 milligrams. My wanted is tablets. And I'm going to, again, put that over as my numerator. This reminds me that I need tablets to end up somewhere in my numerator. So if I have to get rid of milligrams, and I can put this over 1 if I want to, or over nothing. So now 250 milligrams is sitting in the numerator position. This is the denominator position. How do I get tablets in my numerator? And how do I get rid of milligrams? Because I want tablets. I need just tablets. Well, I use what's in my problem. They're telling me that what's available is 100 milligrams in a tablet. So I'm going to write 100 milligrams. And I write it in this order. Number 1, I can cross off unwanted units if I set them up diagonally. And when I set it up this way, I'm able to cross off milligrams and I'm left with my wanted in my numerator position, which is tablets. So now all I have to do, which is the 5th step, is to multiply the numerators and divide them by the denominator. So I'm going to multiply 250 times, well, there's nothing here if I put a 1 tablet. So 250 times 1 is 250. And 100 times 1 is 100. Now, when I do that, I divide 100 into 250. And this is where your calculators come in. So I know that 100 goes into 250 2 times, and then 100, that will give me 200. And if I keep going down through my division, that'll give me 500. So I know 100 goes into 500 5 times. So my answer is 2.5. But 2.5 what? 2.5 tablets. So that means I'm going to administer this patient 2.5 tablets in order to give what the doctor prescribed, 250 milligrams. So let's do another problem. And now this one is different, but it's still the same steps. So I have to interpret my doctor's order. So this is reading a bottle is labeled 0.125 milligrams in 2 milliliters. So that basically means that there is 0.125 milligrams of a drug strength in 2 milliliters. The doctor has prescribed 0.15 milligrams. And the question is asking me, what am I going to administer? What am I going to draw up into a syringe to give to that patient? So what is my given? The given is what is ordered, what is prescribed. And that's where I start my given, 0.15 milligrams. What is my wanted? Well, it comes in a liquid. So my wanted is milliliters. So now I have 0.125 milligrams. Now, how am I going to get milliliters in my numerator, and how am I going to get rid of my milligrams? So I have to set milligrams up down here, and I can use what's available. What is on hand? 0.125 milligrams, and there's 0.125 milligrams in 2 milliliters. This gets rid of my milligrams, and I'm left with my wanted. So now my famous saying is, now it's just math. So 0.15 times 2 is 0.3. And 0.125 times 1 is 0.125. So now I have to divide 0.125 into 0.3. And when I do that, I use a calculator because I'm no mathematician. This gives me 2.4. But I can't just answer 2.4. 2.4 what? Turtles? Ducks? No, 2.4 milliliters. I am going to administer to that patient 2.4 milliliters of this medication in order to give the prescribed dose. All right, let's do another problem. So this problem says an order for 85 milliequivalents, and this is just another type of unit, 85 milliequivalents of an electrolyte is ordered. Available, maybe it was sent by pharmacy, or maybe this is what was delivered to the patient's home, is a label that says 25 milliequivalents in 5 milliliters. And that's what's available. So again, my given, our first step is evaluating these doctor's orders. Given is the order, 85 milliequivalents. Wanted, what is the wanted? Well, it only comes in a liquid, so my wanted is milliliters. And my unit path is I've got to get to milliliters. So what's available? Or what's on hand? It's 25 milliequivalents in 5 milliliters. So let's start our problem. One factor, we start with the order. 85 milliequivalents. You put that over 1, and my wanted is milliliter because that's how it comes. So how do I get milliliter in my numerator? And how do I get rid of this milliequivalent? Well, I use what's available. There's 25 milliequivalents in 5 milliliters. When I set it up this way, I can cross off my milliequivalents. I'm left with milliliters, and that is my wanted. That's exactly where I want to be. So now it's just math. 85 times 5 is 425. 25 times 1 is 25. When I divide 425 by 25, I get 17. But I can't just write, what am I going to administer 17? The answer is I'm going to administer 17 milliliters. So this will definitely not be in a syringe. This is probably oral suspension. We're going to get a nice little medicine cup, and we're going to go to the proper fill line and give that patient 17 milliliters of, maybe this is potassium replacement, but that's what we're going to administer to our patient. Let's look at this other one factor. And remember, it's a one factor because there's only one element to this order. And this will make more sense as we move into 2-factor and 3-factor. But a dose of 0.25 milligrams is ordered. So that is our given, that is our ordered. The drug is available in 200 micrograms scored tablets. So The order is for 0.25 milligrams. And my wanted is tablets because that's what's available. Now, when you see the term scored in the word tablets, with the word tablets, it just means that this tablet is able to be broken. It could be broken. So sometimes you'll receive a pill that has a score in the center that you can break it in half, but there are some medicines that are scored so you can break them in quarters. So you may have a pill that you break and give a half, or you may have a pill that you will give a quarter or 3/4. That is fine. When it says it's scored, that means it is breakable by hand. All right, a gloved hand, if I might add. So our given is 0.25 milligrams, and we can put that over 1. But here's the challenge. The order is in milligram, but the available is in microgram. So we have to think I need a conversion. So when you go back into your mind and you think about all those conversions you had to remember, I remember that 1 milligram is equal to 1,000 micrograms. So right away, I'm thinking, I got a conversion. This is part of my unit path. I need to convert something, but I need to get to my wanted, which is tablets. So how do I get rid of milligrams? I can't use this. I can't use micrograms. So I have to use my conversion. So we always set it up so I can cancel out diagonally. So 1 milligram is equal to 1,000 micrograms. All right, that gets rid of my milligrams, but now I'm stuck with micrograms. I got to get rid of that micrograms. I only need tablets. So what do I use? I use what's in my problem right here. Now I can say 200 micrograms in a tablet. I get rid of my unwanted micrograms and I'm left with my wanted. So you see, it's all about setting it up so you can cross off the unwanted diagonally to get to the wanted. So now, as I always say, now it's just math. So 0.25 times 1,000 is 250. And 200 times 1 is 200. And when I divide 250 by 200, it gives me 1.25. Well, this means I'm going to give this patient 1.25 tablets. Never forget that unit of measure. So I'm going to take these 2 pills, I'm going to give them 1 whole pill, and then I'm going to break off and give them 1/4 of a pill, 1 1/4 tablets. Okay, so that is dimensional analysis 1 factor. Let's do one more. So remember, the first step, interpreting the doctor's order, we have to find and identify that given quantity. What is that exact dose that the doctor ordered? And in this case, the exact doses, a medication ordered is for 875 milligrams. That's my given, that's my starting point, 875 milligrams. Put that over 1 if it makes you feel good, it makes me feel good. The second step, what is my wanted quantity? Well, I'm looking at this and what available is milliliters. That's what's available, that's what I'm using. All right, unless the question asks you something very specific, you're going to go with what's available, okay? So the third step is to establish that unit path, determine if you need any conversions. And I'm looking at this, my order's in milligrams, but it's available in grams. So right away I'm thinking, all right, milligrams to grams, milligrams, grams. Well, I know that 1 gram is equal to 1,000 milligrams. So I'm going to keep that in the back of my mind. So I have to get just milliliters as in my numerator. So how do I get rid of my milligrams? Well, I use my conversion, 1,000 milligrams in 1 gram. Gets rid of my milligrams. Now I got to get rid of this gram. And this is where I can use my problem. There's 2.5 grams in 10 milliliters. That gets rid of my grams. Now I'm left with my wanted. And as I say, now it's just math. So 875 times 1 times 10 is 8,750, 8,750. And then 1,000 times 2.5 is 2,500. I divide 8,750 by 2,500, And that gives me 3.5. So I'm administering what? 3.5 milliliters to that patient. So let's do another. How do we know it's a one factor? Because the specific order is one dose, one element to it. So one factor dimensional analysis, the first step, interpret your doctor's order. What is my order? What is the given quantity in the exact dose that the doctor ordered? And in this case, a dose of 65 micrograms was ordered. And it says was prescribed. So prescribed and ordered mean the same thing. On hand is a bottle that reads, the label reads, there's 0.5 milligrams in 5 milliliters. So my wanted is milliliters. That's how it comes. So I need milliliters in my numerator. I can put this over 0. So looking at this problem right away, this is milligrams, this is micrograms. So my third step, what is my unit path? And am I using equivalents and conversion factors? So let's think. I know that 1 milligram is equal to 1,000 micrograms. So I need to set this up to get rid of the micrograms. I need to get to milliliters. So what do I use? I use my conversion. There's 1,000 micrograms in 1 milligram. Get rid of micrograms. And now I can use what's in my problem to get rid of the milligrams. There's 0.5 milligrams in 5 milliliters. And that leaves me with my wanted, exactly where I want to be. Now it's just math. So 65 times 1 times 5 is 325. And 1,000 times 0.5 is 500. When I divide 500 into 325, it gives me an answer that I'm looking for, 0.65 milliliters. So don't forget, your rounding rules apply. We always have to think about that. But in this case, it came out perfectly. Anything less than 1, we round to the hundredths. That's 2 places to the right of the decimal. So when I'm asked, what am I administering? I am administering 0.65 milliliters to give this ordered dose that was prescribed.